This conference will now be recorded.
Yeah, so today we are covering more in depth about ETL, the concepts behind ETL. So many of you have joined yesterday's session, but I think a couple of you are new. So maybe I will first show the syllabus, what we'll be covering throughout this course. So this is a 40-day course. Every day we will be having 1 hour sessions where we'll be focusing on Azure Cloud Data Testing or ETL testing. We will cover from basics with hands-on projects. So we'll cover SQL basics as well as Azure Cloud Data Testing as well. Okay, so in week 1 we will be covering the testing concepts, Azure fundamentals, and different cloud architectures. And in week 2 onwards, we'll start with SQL basics and we'll slowly move towards advanced sessions of SQL. We'll definitely have different query practice sessions after every theory sessions. So up to week 3, we'll be focusing on the key concepts and the SQL side. Then in week 4, we'll be starting with the Python and Pandas, how to utilize the Pandas library for analyzing the data uh, in terms of a testing side. After that, we'll move forward with the Databricks. So we'll get familiarized with Databricks, how we should write a notebook, how to include various Python scripts to perform data analysis or data cleansing operations. So we will have a hands-on sections on this as well. In week 6, we will start with familiarizing Azure portal. You guys also have to create an account in Azure portal, and then we will start with Azure Data Factory. We'll explore how pipelines are created, how we can utilize Azure Data Factory for testing, how we can debug Azure Data Factory pipelines. Everything will be covering in this. Then in week 7, we will go through the hands-on sessions, basically related to the real-world study case studies. So based on the overall topics that we have covered, like SQL side and the ETL side, we will be having some hands-on sessions on the project-based learning. So we'll cover all those in week 7, and then in week 8 we will build another project with a full ETL pipeline, data pipeline. Then we will work on that, and then we'll have some extra sessions for interview tips and resume preparation tips. So that is how this course is being structured. So I hope you guys have got a clear picture now. So today we will be discussing ETL testing concepts, data warehouse related concepts, and any other key concepts within testing and data warehouse side. So we'll start with the session. Yeah. So okay. Before we start the session, I will start with a quick story, like as shown in this image. This is a story related with a retail company. So assume you are working for a retail company, and there is a huge weekend sale happening, which is having a 60 percentage off on couple of products. So thousands of customers are placing their orders, but somehow within hours, customer service is flooded with complaints. What happened is some orders were cancelled, products which are shown as available in stock when ordered were actually sold out. So this kind of data mess up or maybe incorrect product displayed in the application happen. So finally, uh, what happened is the retail company has investigated on this issue, and they found that their inventory data or the backend data in their data warehouse is not having the latest information. When they checked, they found that it is having 1 day older data, so that is not updated. This is happened just because of a miss in the ETL job run. That means the data flow is missed in between. So the report showed that the products that are in stock were actually not existing or were actually sold out. So this is a classic example of ETL failure. Okay, I'm starting with this ETL failure scenario just for you guys to get an understanding how actually ETL works in real world. Okay, you can see in this image on the left hand side one source side table and the right hand side one target side table. Both the tables are having the same structure, meaning product ID, product name, the quantity and last updated are the same columns we can see in the screen. So one customer, let's say this information is available to the customers while they are purchasing a product. So customer is seeing this view, this target view. So when customer try to purchase wireless mouse, he or she will come to know, okay, 10 quantities in are available in stock, so I can purchase one. So like that, people will start to purchase. But what happened is the scenario is from the source there are no uh, items left. I mean there is no stock available for wireless mouse. So if you see the column last updated, this table, the source table, source is the ultimate input which is needed for customers to have the latest or real time information. So the source is having this latest information which shows it is having 22nd April data. But unfortunately in the target, this data is 1 day old, that is 21st April data. So this is how this failure happened. It's because of a job that got failed in between. So this whenever an ETL job fails, the expected data will not flow into the target. If that is the case, data mismatch or data missing scenarios can happen, or data loss can also happen. That is something happened in this retail scenario. Okay, this is a classic example of how ETL works in real time. Uh, so anybody have any doubts in this? Otherwise, I can move forward to the next slide. Okay, good. So next is like again, I will start with another story. We started with an ETL failure story. Now this is the actual scenes behind ETL testing. Here you are seeing images of a restaurant where dishes are being prepared and served. So here you first, before you start preparing the dishes, what you guys need is like basically start from purchasing the necessary items, which includes grocery shopping, and then cleaning the groceries that we have already purchased. And while preparing the dish we have to add some spices and prepare the dish. Finally, while serving, the dish should look good as well as it should taste good, right? So in this case, the grocery shopping is the phase we will extract the data. The E in ETL testing is extract, the T means transform, L indicates load. So extract, transform, and load testing is something that we are uncovering based on a uh, kitchen story, I can say. So we are extracting the necessary, uh, sorry, necessary. We are actually purchasing the necessary items before we transform the product. We are purchasing or extracting. We are transforming or we are making the dish or preparing the dish. This is the preparing and cooking part. That is transform. Then finally serving part comes as data loading. So this data loading happens in a data warehouse. So that is how ETL testing works. This is a common standard representation of ETL testing. Extracting the data. All these three cylinders indicates different source information. So from different sources. We will get the data, we'll extract it, we'll transform it, and finally we will load it. The primary goal of ETL testing is to ensure the data is clean, consistent, and ready for analysis and reporting. The data is here in this case. You can see data is extracted from various sources. This can include databases, flat files, or even other sources. It can be a different entity itself. It can be an XML file, JSON file, anything. So that is how the source data can be. While extracting this data, since it is coming from different systems, we have to transform it to make it clean and readable so that it will meet the requirements of the target system. The target system is nothing but a data warehouse. So during this transformation process, data cleansing will happen, data aggregation, or we have to format some data to make it readable or to meet the requirements. The data once transformed can be moved to the target system, such as this target system can be a data warehouse, or mostly this will be a data warehouse, or in some cases we can utilize this data for any other different sources. So in that case we will dump this data to a data lake. Basically, whenever this data warehouse is coming as a source for the next layer, then we call it as a data lake. By default this is a data warehouse. So maybe I will pause for few minutes. Maybe you guys can start asking questions if any doubts are there.
So, Aarti, like, what are the logics we are performing in transformation? So, if you take the previous example where source like 10 mouses,
Hmm.
so that like what logic like will perform when the data will move from source to target?
Yeah.
Therefore,
So
yes,
in this example, right?
yes,
Yeah, so here I'm just showing only the information that are coming from source. It should reflect the same in the target. But ideally, I mean, there is no transformations involved in this example. This is just to showcase like the items should be or the data should be in sync. But ideally, transformations meaning the business requirements only. So if business says the target or the data warehouse should contain only the products that are coming under electronics category, or maybe under electronics a certain category only. So uh, if there is a certain requirement to showcase only such products, then even though if I have more than this products, the ultimate target should have only should meet only the uh, products which are coming under the category based on the business requirements. That is where the transformation comes. That means I have to filter out certain records. I have to exclude records which are not needed. Or sometimes there might be a column called price. So price and quantity, when it comes, both comes when customer makes a purchase, then let's say the particular customer purchased two Bluetooth speaker. Then considering the quantity the customer purchased, the price should be multiplied with the quantity, right? So that kind of calculations can also be another transformation. So transformation basically depends on the business requirement. Hope you got it, Mukesh.
yes. Yes. So yeah, so here the like logic is working reverse in the reverse direction. So customer is checking the target table. From there, it is making the purchase, and once it is done, that sync will happen from target to source.
No, no. Actually, here this scenario is a ETL failure scenario. So let's say you are purchasing something from Amazon. What you are seeing or what you are making purchase is either from Amazon website or from the mobile application. So in both the cases, it is the target system. Data in the end user, data is actually getting from the target side. Target means destination. So end user will always see what is present in the target. But if the target information is wrong, here if you see the last updated is correct, but somehow some ETL job got failed. Due to that failure, this information was not passed on to the target. That is where the customers had made wrong purchases.
Okay, got it.
Yeah. If there are no questions, I will move forward. Okay. Yeah. So next we have data warehouse. So far we have seen data warehouse as something we are defining as a target system. So when we say as a target, basically data warehouse is a central repository where we store historical data from multiple sources. From multiple sources, not just extracting as it is, but after performing some ETL operations, right? So data warehouse combines this data from multiple variable sources into one single database, which then can be used for further manipulation, that is for further analysis or further transformation, or usually business intelligence team will utilize the data warehouse data for reporting as well. And when it comes to larger companies, they use the data warehouse for analyzing trends over a period of time. Like when it comes to the sales example, uh, this data warehouse data or information can be utilized to see the trend of sales over the years or the past 2 years, or maybe over a period of uh, last 5 years. Like that, we can have a trend analysis between the data that is holding in the data warehouse. So that is where mostly people use data warehouse in their organization. Coming to the characteristics of data warehouse, we'll see that later, like we'll see it in detail. Basically, it has four characteristics. It is subject oriented, integrated, time variant, and non volatile. So when we say subject oriented, most of the data warehouse will hold a specific subject data. Like in the retail example, we let's say we have sales data warehouse. There can be inventory data warehouse, which will hold only inventory related information. Same goes with customer information, customer data warehouse, or product data warehouse. So that is how the characteristics subject oriented defines. When we say it is integrated, let's say we have data coming from multiple sources. As a customer, let's say I am purchasing one product from Amazon. I can either purchase it from Amazon mobile app or from Amazon website. So there are multiple options available for me to purchase. So the way how user purchase depends on the user's preference, right? So there are multiple, since there are multiple options available, data can be coming from different sources. So they have to integrate their application to handle the data coming from different sources. That is why data warehouse is integrated. When we make the payment app should also be having a connection with the Amazon application. If that is isolated, then our order will never be placed, right? So that is how integrated characteristic is designed. So then coming to time variant, uh, this data warehouse is always holding historical information. That is, we can retrieve data for any uh, previous year. Like most of the companies, due to storage issues, maximum they will store up to 10 years, I believe. So more than that they won't store because of data storage issues. But having that 10 years of data stored in a data warehouse is a big thing, because we can utilize that data to perform and do the analysis, and we can investigate the data with the newly coming data, just to see the trend, just to do the trend analysis and various other business operations. So that is how time variant characteristics works. When we say data warehouse, it is having historical data, right? But ideally, in the real time, whatever transaction that we are making in our mo- internet banking application or any other transaction related application, that is actually a real time action. But data warehouse is holding all the previous information. So that is the difference. And when we say non-volatile, so once we place one data into data warehouse, it cannot be changed. So that is why it is known as non-volatile. So past sales information we cannot go back and change, right? Because something that is already being written in data warehouse, we cannot change that. Only we can add new sales information. These are some of the characteristics of data warehouse. Okay, now we have discussed about data warehouse, but most of you are familiar with the term database. So now let's understand these two tables, and let's see how database and data warehouse are different. So this first table, we can say you can see order ID, customer ID, product ID, quantity, order date, and payment method. But if you see this one row or the second row, this is like a customer's information. A customer who made the orders has purchased a particular product. What is the quantity of the product, and on sorry, which day that particular order is made, and what was the payment method. This is something a real time information, right? So similar data, you can see it in the second row. This is what we called as transactional information or real time information. This real time transaction information are always stored in a database, not in a data warehouse. But if you want to store this real time information or transaction related information into a data warehouse, we need to summarize it, or we need to make an analysis. So that is where the actual data warehouse data role plays. So here, if you see, this is kind of an aggregated or summarized information, right? So the total orders placed for a particular region, and for which product category these orders were made. So all the summarized information, the total sales, everything is here, right? Sorry, just give me a moment. Yeah. Sorry, yeah. So here, this aggregated information can never be stored in a database, because in database, every time, every moment, every single moment, we are getting real time information. But in data warehouse, whatever information we are already got, we will summarize it and then we'll store it in data warehouse. That is a main difference. So these two for these two database and data warehouse, there is a specific term that we use in the data warehouse or ETL testing world that we will see into the next slide. Okay, so before we actually talk about those two terms, let's have a look into this another story. This is a supermarket checkout process, uh, this side, and this is like sales manager in the supermarket who is analyzing the sales trend. So while we imagine you go to a supermarket, grab some items, and then you head out to the billing section. The cashier will scan your items and process the payment instantly, right? So this is fast and real time. The data is your data is processed and it is stored in their database. This real time storage of your billing information is called OLTP, online transaction processing. Okay. And when it comes to the sales manager, who is more interested in knowing his supermarket's sales details, he will obviously check his dashboards, or we can say he will be looking for the top selling items in the last month, or which store location has performed the best in this quarter. Like that, he will try to see the trend of sales over the years. So this kind of analyzing the existing data is called OLAP, or online analytical processing. So this here he will be able to analyze historical data for trends, and he can make decisions if his sales is down or if sales is improving. So you can get an analysis from this dashboards. So any doubts in this? Maybe I will pause for a minute. Okay, cool. Yeah. So now let's see the definitions, or maybe this slide you can utilize it for getting a more picture about what is OLTP and what is OLAP. OLTP, or online transaction processing system, is nothing but a simple data warehouse which actually stores the daily transactions. This is mostly used in the online applications where application needs to update very frequently. Okay, just to maintain the consistency in the data. So always this data will be normalized. When I say normalized, here I will show this picture again. So here you are seeing only one customer's information. If the same customer is placing a different order, then that will be again a new information in this table, right? But what about here? All the informations based on a particular date, region, and category are summarized. So that is the difference. So normalization means everything will be simple and it will be not summarized. That's what normalization means. An example of OLTP system is online movie ticket booking website. So you all will be already knowing that, right? Two persons are booking, trying to book for the same seat for the same movie, for the same time. Then whoever completes the transaction first will only get the ticket, right? The same concepts goes with OLTP systems. In OLAP, or online analytical processing system, usually deals with the data for making decisions and planning. This actually deals with aggregations, and the data in OLAP will be from different sources. It will be not relying on one single source. It will be from multiple sources. We can say that any data warehouse system is an OLAP system. Many companies used to compare their sales data uh, just because they are having some OLAP systems or data warehouses. So that makes them capable, or help them track their business growth. So this is the major difference we can say between OLAP and OLTP. So the purpose is OLTP is just transaction processing. OLAP is analytical processing. Coming to the terms like data volume, this OLTP will have small transactions, but OLAP systems will hold larger data. As I said, it can hold up to maximum 10 years of data. Depends on the company's needs as well. So if company says I need only last 5 years information only in the database, then it will have only 5 years information. Then coming to the operations, in OLTP, we can add a new data, insert it, we can update the existing information, or we can delete it. But in OLAP, we cannot make any modifications. We can only see the information. That's why we can select the data, we can group it for aggregations or summarization, or we can combine the data, or we can join it. Okay. When we say this, OLTP focuses on real-time transactions, and this focuses on data analysis. The examples we already discussed, this is mostly used for movie booking systems and all, and this is basically used for trend analysis and reporting purposes. So any doubts in this? Maybe I will pause for a minute. Okay, I think everyone is clear. Okay, let me proceed to the next slide. Yeah. So if people who were already present in yesterday's session, you guys might be already seen this picture. So this is nothing but a normal data warehouse It will have data coming from multiple sources. It can be either CRM system, billing system. These all are kind of databases. Then flat file can be one of the source. From this source data, we will perform some ETL operations. Then we will move the data to the data warehouse. Finally, from the data warehouse, we can use that data for reporting, analytics, or data mining. This is how a typical data warehouse will look. Okay. So next we have one of the most important topic in data warehouse area. So that is nothing but fact and dimension. Fact and dimension are type of tables in a data warehouse. So fact tables are usually utilized to serve some purpose. Same goes with dimension tables. The major difference is fact tables usually contain measurable data like the quantities or the price information, right? So all the price related information or numerical information will be saved only or will be stored only in fact tables, while in dimension tables are utilized in data warehouse to store descriptive information. Why we are maintaining these two tables as separate is just to process the data, like just to get the data properly, uh, what to say, linked with the appropriate information, like to get the aggregated or summarized information in the final data warehouse. So here let's consider the example fact sales table. So here if you say the table name itself has a keyword fact. So in most of the projects, if they are using a fact table, they will either have the name starting with fact underscore the respective name that serves the purpose of the table, or they will at least have sales underscore fact or something similar to that. Okay, most of the cases it will be fact underscore the actual table name. Some cases they will hold only F, the character F underscore sales. That depends on the project. So this fact underscore sales information is shown here. You can see the sales ID, date key, product key, store key, customer key. So these are key columns. I will explain about these key columns later. So sales ID, quantity, and total amount. Okay, this ID indicates a particular sale that has been occurred. The quantity is the number of purchases that is made under this particular sale ID. And for this particular quantity, for this particular sale, the total amount was 400, right? So all the numerical information, if there is another numerical information, that will also be stored in this fact underscore sales table. Okay, then coming to the key columns, you can see date key, product key, store key. These are some of the key that is used to identify what is the related dimension table associated with this fact table. Okay, so when I say dimension, it will contain only descriptive information. So if we consider our sales, uh, retail sales scenario that we were explaining from the start of the session. So we have the sales details, the quantity, and the total amount. So the dimension table will have only the product or region wise or customer specific descriptive information. So we have 1, 2, 3, 4 different dimension tables. So this dimension table, so mostly dimension tables will have the naming dim underscore date. I mean the specific table name. So this is the normal format that is followed in any of the projects. So it depends, like sometimes they will use dimension underscore date itself, but mostly they will prefer with dim underscore date. So this date table have a specific function. It will store only the date related information, when the sale has occurred, on which day, which month, which quarter, and which year. Okay, and for every entry there will be a key. Like we have a sale ID, here we have a key column just to identify uh, what is the values against this key. That means what is the full date, what is the month, what is the quarter, and the year in which the particular sale has occurred. So now if you look back into this date key column, you can see 20250401, which is nothing but 2025 April 1st, right? So this is in YYY format. So this I was able to identify just because I'm familiar with the YYY format which we use in the database, right? So same goes, like this is purposefully made it this way, like without any usual date syntax, like there is no slashes or hyphens in between, because this is a key column. So this key will have the full information. So we can, let's say, mostly the information will be full date will be 2025 hyphen or slash 04, then slash 01. That will be stored in full date column. In the month, we will have April or 04. In the quarter, we will say this is second quarter. In the year, we will have 2025. So like that, the information will be stored in dimension date table. Similarly, for dimension product, store, and customer, we have certain informations. So product will have again a key column and some descriptive columns. Here, if you see, only the descriptive columns. There is no quantity or the price or any other information. Numerical information is not present in dimension table. So what we are trying to achieve is descriptive. We will split it into a different dimension table, and then we'll make a relationship with dimension table to the fact table. So to get to establish a connection with dimension product to the fact sales, we have to store this product key in fact sales table. Then only the sales information can fetch for which product this particular sale ID belongs to. Okay. Same goes with store. Store details like store name, city, region is again having a store key. So this store key should be placed in this fact table just to understand what is the sale processed under this store key. Same goes with customer, where we have name, gender, age group. So yeah, this is how this fact and dimension works in a data warehouse. So anybody has any doubts in this? Oh, okay. Let me ask like one question. Like, anybody from not from ETL background is available in this group, or are you all familiar with these terms? I'm just
I
curious
don't
to
know
know.
anything about ETL or thing.
Okay, Divya, thank you. Anybody who
Even
has,
myself, I also
okay,
not known of ETL.
okay,
Yeah,
yeah,
myself also not from ETL background.
okay. So, are you guys getting all these terms?
Myself also.
Okay, Sumit.
So just one question, that if
Hmm.
there will always be a fact table if there are dimension tables.
Yeah, yes. If there is a fact table, always a dimension table will be there.
Okay, okay. And fact table is always there to establish a relationship between multiple dimension tables, the data across them, or
Yeah.
something.
So good question. Actually, I forgot to include that in the slide. So if actually if fact table will have the key columns to establish a relationship with the dimension tables, and apart from that, it will have measurable information or numeric columns. As you see in the quantity and total amount, so we have numeric columns, right? So if a certain fact table that is having only the key columns, suppose we don't have quantity and total amount, we just have only up to here. Okay, such kind of fact tables are called factless fact. Okay, maybe I will write it here. They are called factless fact tables. Okay, this is one of the interview question that is mostly asked. So maybe you guys can note this down. Even you can Google this after the session as well. So factless fact tables will hold only key columns. Okay, it will not have measurable. But if a fact table is having key columns and measurable information, then it's a normal fact table.
Just a question here. What is the measurable information?
Yeah, measurable is like quantity or numerical information, like sales amount, quantity sold. Here you see quantity and total amount, right, in this representation. So whatever
And
is numbers, yeah, that is.
what about the key columns? What is how to differentiate that from the measurable columns?
Yeah, so key columns will uh, they are introduced to just to establish a relationship between this fact table and dimension table. If I
Oh,
don't consider, you are not including these four key columns, then how will you know this sale is you know that this sale is having two quantity and 400 rupees, but how will you know for which particular product on which day this sale has happened? There should be, the information should be complete, right? You should have the product information, on which day the sale happened, the store related information, which customer purchased, all those things, right? So that is where we need the key columns.
so here in this case, sale ID and product key are the key columns, and the total amount quantity are the measurable
Yes, yes,
columns.
yes.
Okay,
These four key columns, yes.
okay.
Yeah. So just introducing fact and dimension, we have one more term, like schemas in data warehouse. Like how you design a, basically as a tester, we don't design a data warehouse. That is designed by technical leads or developers. So when they come up with a decision to design a data warehouse, they have to either go with one of the schemas, like how to distribute the tables, how to establish the relationship between the tables. To understand or to finalize that design decision, they have to either go with star schema or snowflake schema. In most of the projects, they will go with star schema. Okay, so the star schema, with the representation, you can say one fact table is centrally associated with multiple dimension tables. The same example that we have just seen. The sales fact table is having information from dimension product, dimension customer, dimension store, and date. So this is a central fact table. So this is called a star schema. So what will happen in the snowflake schema is, if you have a certain dimension which is again having some relation with another dimension table, like this dimension product is not having the full dimensions of a product. The category, product category, and certain other informations are splitted in this table. So in order to find the category related informations of a product, we have to establish a link with dimension category. So if a particular dimension table is further splitted or connected to a different dimension table, then we call it as a snowflake schema. This is again another important interview question for ETL testing. What are the schemas involved in data warehouse? What are the two different schemas? Explain those, and then what is the difference? You have to basically tell this as a difference. A dimension, a centrally fact table associating a central fact table having multiple dimension tables connected to it, star schema. And when a particular dimension table is having connection to another dimension table, it is snowflake schema. Yeah. So
So
any
just a
doubts?
question.
Yeah.
Uh,
Yeah.
in this case, in the second case,
Hmm.
snowflake schema,
Yeah.
the dimension table is connected to the other one, second
Yeah.
dimension table. So is
Yeah.
it referring the data from dim category, or
Yes.
dim category is referring from product.
So
How?
dim. So basically, this product information. Let's say in the previous slide. So this dim product is having product key, name, category, and brand. This was our initial uh, set of columns present in a dimension underscore product table. But when we have a new table, dimension underscore category, that will be specifically storing category related information. So this category column will not be present. Instead, category key will be present in dimension product, and category key and other category related columns will only be present in dim underscore category table. So this is like again a connection from dimension product to dimension category. So here if you say in terms of fact sales is not having a direct connection with dimension category. That is a major difference. But here all the dimensions are having a direct connection with the fact table. And why most of the projects are designed with star schema is because it is simple to design, and for querying the data from star schema it is easy and it is faster. While this dimension table again having another connection with another dimension table, that will become a bit slower as well. When it comes to a larger design, it might affect the performance of the data warehouse, or it cannot be storage wise also it is not that efficient. That is why mostly people prefer with the companies prefer with star schema. Okay. But okay, since here, okay, this dimension, if you see dimension product, it is having product details like name, brand, also the category. But what if there are 100 columns related to dimension, the product details are present in this table, this table itself will be kind of messed up, right? So in such cases, instead of, rather than making the table complex or making the data structure complex, it is always ideal to split the contents of the table into a different dimension table and just make a reference to that dimension. That is where this relation from product to category dimension comes. All the category specific informations are present in a separate dimension table. That will, when it comes to 100 plus or maybe more than 20 plus columns, that would be a more efficient way to approach the dimension tables or to structurize the dimension table. That will actually save the space and will uh, uh, structure wise also, when we check the data, that will look simple and nice, right? That will make us easy to query as well, even though there is a multiple connection before we actually connect to the fact table, but things will not be complex in that terms. When the data is complex, we have to split it always. Otherwise, it is always ideal to have a direct link like this. Okay, are you guys getting it or confused? Okay, I
So
assume.
which all databases use these ETL concepts and schemas, just to understand the background of it?
Sorry, which all
Which all
databases you asked?
databases? Yeah, yeah.
Uh, uh, it's not databases like, see, this is basically the schema we use only in data warehouse.
Okay.
So, yeah, because maybe I will show that. Yeah, so we will be getting data from different sources, right? But ultimately, we are storing it into a single destination. That is our data warehouse.
Hmm.
Inside this data warehouse, how we want to store it, That is where the fact and dimension comes,
Okay.
because data from CRM, billing, everything will have different information. We are doing some ETL operations and making it structured, more structured, with some including some fact and dimension tables. That is where those fact and dimension tables are having a connection, and those are representing our data warehouse.
What are different steps in ETL actually?
Yeah. So when it comes to testing, we can say that source layer is one layer of where we have to do the testing. Then comes the transformation layer, and then comes the data warehouse layer. But there are more steps involved, because the data from source can either be it's a database data, or it can be a flat file data, right? So we have to fetch that information and move that to a single or one another layer, just to see whether CRM, billing, ERP, or flat file data, everything is visible, everything should be visible in that second layer. That layer we usually call it as landing layer. So we have to land all the source information to that landing layer. That will be our, we can say it as a zone, landing zone. So landing zone is kind of a database where that database will hold one table for CRM data, one table to store billing data, one table again to store the flat file data. So flat file now will be converted to a table. That is how the landing layer will work. So testing should be performed from source to landing layer. That is one step involved. From landing layer to another layer, where the extraction is done, right? In the ETL, the data is extracted to the landing layer. After that, we have to perform the transformation. So that transformation is done in another layer, that is staging layer. We will discuss all those in the upcoming sessions, but anyway I will cover that now. So from landing layer we have a transformation layer, which we call it as staging layer. In that layer we will apply all the transformations and make the data ready as per the business. So this data from CRM, billing, ERP, now everything is splitted and present in landing. Now we have to combine, we have to join this information and make it readable, or make it uh, like informative as per the business requirement. So that will be done in the next transformation or staging layer. Once that is done, staging layer is actually kind of a replica of the data warehouse, I can say. It's a replica of data warehouse. But as I already mentioned, in data warehouse, once something is available, data is present, we cannot make any changes. So if you want to make any changes, we have to perform the changes in staging layer. Before we even load the data to data warehouse, we have to perform all the required transformations. So source, landing zone, source to landing zone is one type of testing we have to perform. Landing to staging is another type of testing that we have to perform. From staging to data warehouse, so data warehouse, coming to data warehouse, staging to data warehouse involves fact and dimension tables. So fact table and dimension tables are nothing but the data warehouse. So you have to basically compare the data between stage and fact and dimension tables. Maybe at this moment of time you will be confused how you can validate stage and fact and dimension, but we will come to that in detail at a later point in time. So that is how the various steps involved in data warehouse testing. uh, Bhavya, I think you were asking the question, right? I hope that is clear.
Yes, yes, Sarthi. Yeah.
Yeah. But there are many things to discuss. This is just a simple representation, but as I was mentioned, landing layer, staging layer, I didn't included that in today's session because that will be overwhelming for you guys. So we will slowly come into that, so that you guys will also be able to pick it up. Okay. So any other doubts in the session? OLTP, OLAP we covered.
We will learn only how ETL testing is done, right? We will not learn how ETL is done.
Yes, yes. So basically, ETL is being performed by developers, and we will basically debug that data, or we can say we will verify that data is flowing from source to target without any data loss or without any mismatches. We are ensuring the data consistency and integrity between source and the target.
Okay, okay, got it.
Yeah. And for that we need SQL as a language. So we need to basically master in SQL, I would say, because only SQL can help us interact with the database or data warehouse, wherever it is. We need if we want to interact with the data, we need to be good at SQL.
Hi Aarti, I am
Yeah.
Kavita.
Yeah, hi Kapita.
So what slides you have, like, are you going to provide those, or we'll just Google it and we'll, like, uh, go through what you taught us today?
You will get the recordings of today's session. Isha's team, you can connect with Isha team. I think they will be sharing it in the WhatsApp group. So you can contact with them at any time in the WhatsApp group itself.
Okay, so what is the name of the WhatsApp group, or how I?
Oh, okay. You are not there in the group.
Not yet.
Okay. Can you ping your WhatsApp number in the chat? I will add you in the group.
Okay,
Yes.
okay, thank you.
Yeah. Thank you. I think somebody has already asked this question, recording of the session. So yes, we have the recordings. We will share it after the session. Okay, Kavita. Yeah. I will note it down. And in case if you have any doubts regarding the course content or any other queries related to the course, you can always contact Kumar sir. So just note his number, or I will share it in the chat window. Yeah. If you have any other doubts, we can discuss. Otherwise, we can wind up the session. Thank you all
Thank you.
for joining the session.
Thank you.
Thank you.